In this lesson, we are going to apply the counting principles you have just learned to other math subjects, such as number theory. Let's see this example. How many positive divisors that 100 has? You may have seen such problems in entry-level math competitions, sometimes even in contests for elementary school students. One obvious solution is just to list all the divisors, right? So 1, 2, 3, 4, 5, 6, 7, 6, 8, 9. It works. But what if the question asks a large number instead? For example, 30,000. Are you still confident that you will not miss any divisor when enumerating them? Let's see how a counting pro will tackle such a problem. First, let's do prime factorization. 100 equals 2 to the power of 2 times 5 to the power of 2. Therefore, we claim any divisor of 100 must be a product of no more than 2 2s and no more than 2 5s. Correct? A divisor can contain no 2, but it cannot have more than 2 2s. Otherwise, it cannot divide 100. And such example is 8, which is made up of 3 2s. Make sure you agree with this claim because it is a key to the next step. This table shows how these divisors come from. No 2, no 5, that's 1. No 2, 1 5, that's 5. No 2, 2 5s, that's 25. 1 2, no 5, that's 2. And so on. This means we have totally 3 choices to use 2, from not using it to use it twice. Similarly, we also have 3 choices for 5. By the multiplication principle, the number of total choices is 9. Do you agree? Now let's try a quiz. How many positive divisors does 30,000 have? Here is a conclusion we have just found. If integer n can be prime factorized into p1 to the power of a1 to pk to the power of ak, then it will have this many of positive divisors. The result has nothing to do with the values of its prime divisors. It is just a function of these prime divisors' exponents. Okay, let's review the quiz you have just tried. How many positive divisors that 30,000 have? The result is 75 as shown here. I hope you have used this method instead of counting by hand. One objective of training is to learn proper solutions to tackle a problem like this. You can solve it by brute forces, that is, enumerate and then count. However, it is much easier to use a solution you have just learned, isn't it? Okay, let's try its sister problem. What is the sum of all these divisors? It is not a counting problem per se, because it is closely related to the previous question. Let's discuss it as well. Of course, you can list all its divisors and then add them up. But is there a better way that is less prone to errors? Yes, there is. Let's still do prime factorization first. Then we say the sum of all these positive divisors is given by this expression. Pause a moment to see whether you can understand where does this expression come from and why it is correct. To see the logic behind this expression, we can just simply expand it. Do you see the magic here? In its expanded form, each term is a product of some 2s and some 5s. Therefore, it's a divisor of 100. And on the other hand, every positive divisor of 100 will appear in the expanded form once and only once. Polynomial is a very powerful tool. We will see again later in the generating function lesson. the generating function probably is one of the most powerful tools in counting. Before we take the next quiz, let me give you a hint. If you have learned geometric sequence, you may have noticed that each bracket contains a geometric sequence. Therefore, if the power is large, you can use the geometric sequence sum formula to find its sum. Here is a formal statement of our finding. Given a positive integer n, we find the sum of all its positive divisors in this way. Okay, let's review the quiz you have just done. What answer did you get? The correct answer is 0. Why? Can you figure out the reason? Remember, subtle difference may be significant. This is especially true in math competitions. This is a very good example. By asking integers instead of positive integers, their sum must be 0, because every positive divisor comes with a corresponding negative integer that also divides 30,000. This concludes our lecture. I hope you find it useful and fun. If you have any question, feel free to ask. Thank you.